Good morning. This video will be the first part of a multi-part series on the topic of the four horsemen. That is HTTP, TLS, SMTP, and DNS. For today's video, the first thing that we'll be doing is getting a virtual machine running so that we can host the relevant daemons to facilitate those protocols. Before we get started, just to let you know what you're going to need, you're going to need to have Linux on either desktop or a server. In this case, it's on my desktop. But as a prerequisite, as I said, we will be running a virtual machine. Now, if you're interested to see what actually allows you to do that, you can run this command cat proc cpu info. And specifically what we're looking for is vmx. And then vnmi, and then vpid show that we have some extended capabilities. But the main one is vmx. Now, I should mention this just in case you plan on creating a server or a virtual machine on your computer for the purposes of sharing it with other people. I suggest you do not do this. As you can see, we have some bugs here, Spectre v1, v2. These basically make it impossible to securely run a virtual machine that cannot escalate through the hypervisor to access kernel memory on the host. So basically there's two philosophies. One is let's make computers fast and let's make computers safe. I am of the philosophy that we should make computers fast and we shouldn't even attempt to make them safe. Now, there is a couple of things to note, is that somebody, as a function of this, could not remotely hack my computer. I would have to give them specific access to it in order for them to take advantage of it. They would have to be able to run executables only in Ring 3 user space. As long as they have that, they can bypass any security that I implement as a function of the LDE or limited direct execution model that current systems employ. So that's sort of fun to know. Anyway, what we're going to be doing, though, is using something called libvirt, now also known as KVM. So KVM, or kernel virtual machine, as it says here, is basically another way to host virtual machines. Some of you may have experience with either VMware or VirtualBox. Think of this as another hypervisor. The only difference is it's built into the Linux kernel in modern versions as sort of a default mechanism. This also recommends here Zen as an alternative. I used to use Zen. And basically there was a sort of like a war, let's call it that, between Zen and KVM. And KVM won out as being the default supported API exposed by the Linux kernel to provide virtual machine support. So anyway, there's some installation steps. I have already run these on my system, but you would need to do that. And then the next thing that we would need to do is networking. If I do a cat of my network interface file, now you'll notice that most of this stuff is actually all commented out. So you'll notice I have an S0, which is my physical interface. However, it's not actually being given an IP address. There's no DHCP going on here. There's nothing. Instead, what we have is this bridge interface that sets S0 as a bridge port. Now, what this allows us to do is, at the lowest level possible, basically have this system act as a router for our virtual machines. So virtual machines will be able to listen on this interface and will be able to do DHCP with my external router. In this case, it's a Google Fiber device. All right. And then we can just demonstrate that would look like for the routing table. As you can see, we have our default gateway is to the bridge interface. And then if I do an IPA here, you'll notice that we have an S0 but again, it has no inet. And then our BR0 has our inet. And we're getting this. In this case, it is static, as you can see here, but that's only residual. I could implement this as DHCP as well. In fact, it is DHCP on the router. So when it connects, it's actually getting that address and then essentially just overwriting it. A little bit ugly, doesn't break anything, so it's all good. All right. So once we get to this level where we know that our computer supports virtualization, we have the clients that support working with it. Oh, and there's also one more command, which is virt install. Let's see, I think there might be instructions down here for that. Maybe not. Don't remember the exact command that I used. Virt inst, I believe it is. VIRTINST. That will allow you to create virtual machines, which I'm going to now demonstrate. All right, just getting the command here. Oh, it would help if I had grep. All right, so the command is as follows. We need to type virt install, obviously. I like to use tab completion to make sure that we're doing things right. Not necessary as it's a default, but it helps to be clear. I like to set that our virt type is a kernel virtual machine. And after that, I like to give it a name. In this case, we will just name it VM. Now, we need to decide how many virtual CPUs we give it. And in this case, I'm just going to be giving it 8. It's nice to have plenty to play with. And then we also need to give it some RAM, so we'll give it 8096. And then we need to specify a disk path as well. So I'm actually going to also on my other screen here mount my external hard drive. All right, so we're gonna have that be stored to a path of Menti black, because it's a Western Digital black, that's what I call it. VM, and then just vm.img. And then we need to specify the size of this virtual machine, and I'm just gonna give it 40 gigabytes. Also, it needs a network, and it's going to be a bridged interface with our BR0. So just network bridge BR0. And then we're going to give it VNC graphics. We go graphics mode VNC. And then also not necessary is to specify the OS type as Linux, and then OS variant as Debian 10. And then we want to mount a CD-ROM device onto it. And then that's just going to be the installation medium. So it's going to be an ISO image of Debian. There we go. So if I hit enter, it's going to start installing that. So you notice here that it shows this GTK warning. I actually installed this as root, and my X session is controlled by my regular user. So I'm just going to open up another terminal here, like so. and then do VNC viewer localhost 0. And you'll see this pop up. So we're just gonna hide this one over here. And then now we have our installer. So I actually don't like using the graphical install. They're exactly the same. But I just prefer to use the regular one. Really all you need is the arrow keys. And oh yeah, one thing to note, when you connect to it, it resizes. Regular VNC viewer on Linux, for some reason, during the resizing, something about it causes it to crash and disconnect, but you can just reconnect. I believe that will happen one more time during this installation. So that's just setting up our locales in keyboard. Just letting it know, essentially, when I type something on my keyboard, what does that actually represent to the system? And then it'll automatically do DHCP here, which is nice. As we give it bridged networking, it's actually talking directly to my Google Fiber router at this point. And then we need to give it a host name. In this case, it'll be VM. It doesn't need a domain name. We're just going to give it a username, regular user space username, and then a password as well. And now it's going to go through some other extra steps. Select a time zone. I am Mountain Time. All right. Now, normally on virtual machines, I rely on the fact that I'm essentially just pre-partitioning an image. So it's not really important to do an advanced partitioning method, which I would do on a physical machine. I will show you what I would do normally. I would select the device, I'd create a new partitioning table. I would create a new partition. I'd probably create two. I'd create a boot partition of ext2, give it like 1 gig of space, and then I would create a root partition of the rest of the space, and that one I would use the butter fs journaling file system. You could think of it kind of like extended ext4, but it's not. It's different. Yeah. So that's what I would do. But in this case, we're just going to rerun this and do guided partitioning. We're going to use entire disk. And then all files in one partition. It's just going, let's delete this partition here. Actually, you know what? I take that back. I am going to manually partition this. I don't want swap. So what swap is it's the ability to use your hard drive as memory, which can be useful, but if it does use it, it'll make things slow. And so I typically try to avoid swap at all costs unless I'm specifically trying to do that, in which case I'll manually partition some space and do an MK swap. Alrighty, primary, it's the root. Looks good. Finish partitioning. Okay. That was just a message saying that, you're not using any swap. Maybe you don't want that. Maybe you do want swap. And so I just confirmed that I didn't, and then I just told it to actually partition. Now it is copying some stuff from the installation media into that image. All right, now we're configuring our package manager. Typically, you might want to find a mirror that might be closer to you and faster. In this case, we're just going to use ftp.us.debian.org, which is sort of their round-robin mirror. And that'll just take a second. It's doing essentially what you would do from the command line as an apt get update. And then we're going to be able to select and install the software we want. Now, because we don't need an X environment for this virtual machine, we're just going to basically be using it as a server. Popularity contest, by the way, just reports when you install packages from the repository. I would not recommend doing that. Although if you want to be a good netizen, perhaps you want to. So we definitely want an SSH server, and we do want the standard system utilities. We do not need a print server or a web server or a Debian desktop environment. We will be manually installing our own web server. Or manually in quotes. We're still going to use the package management system, but we're not going to be using Apache 2 HTTPD, which I believe is what this web server still uses as its default selection. So anyway, we're going to let that proceed to install. Alrighty. And we do want to use the grub bootloader, and we do want to use devvda. And now it's rebooting. Now, if we connect with VNC again too soon, it's going to resize as it hits the virtual BIOS. And then for grub again. So I'm just going to wait just a second here. Gotta list our things. Okay, so it's actually off right now. So what we're gonna do is virsh start VM, and it's going to start our domain VM. Domain is the analog for virtual machine with libvirt. Now I'll be able to connect again with VNC. All I did was VNC viewer localhost :0. Right, and then I'm going to log in as root. And there you have it. So we have our virtual machine. Can ping Google. We've got internet. This is the IP address given to us by my Google Fiber router. And one of the things that we can also do is decide that we don't actually need to connect through the virtual graphics interface anymore. We can simply just use SSH. I believe it was 111. It actually may not allow me to connect as root because of the SSH config. Or SSHD config rather, but I can connect as ROS. All right, there we go, ROS at VM. Thank you for watching this video. I hope you enjoyed it, and I'll talk to you later.